If you're a developer, you're eventually going to design an API. There's just no way around it. But here's the thing. If you get it wrong, it can become this huge liability for years. But if you get it right, it becomes that timeless asset. So today, we're diving into the essential design patterns that make all the difference. Think of this as your playbook for getting it right from the start.
And this quote, it just hits the nail on the head. It perfectly captures the stakes here. I mean, think about it. Your internal code, you can refactor that endlessly. Nobody cares. But a public API, that is a promise. The second you release it, people start building entire businesses on top of it. One single breaking change can disrupt thousands of users and just destroy all that trust you've built. The choices you make on day one are going to echo for a long, long time.
So, how do we avoid all of these massive pitfalls? Well, we stand on the shoulders of giants by using design patterns. I love thinking of them like a chef's cookbook, right? We're not trying to invent a new way to bake a cake every time. We're using proven, battle-tested recipes for challenges that every single API designer, doesn't matter if you're building with REST, GraphQL, or gRPC, is absolutely going to face. Okay, so here's our game plan for today. First, we're going to really double down on why an API's permanence is its most important feature. Then we'll get into the foundational design choices you have to make. From there, we'll look at how to handle success. What do you do when you need to scale and change? Then we'll cover the absolute non-negotiables of security. And finally, we'll wrap it all up with a core design philosophy. All right, let's really dig into this idea of permanence. Because an API isn't just some technical interface, it's a product. It's something your business offers to the world. And just like any product, it can either become a tremendous asset that fuels growth or a really, really costly liability.
And this is really the core trade-off, isn't it? A well-designed API acts like a magnet. It pulls in developers, it helps build an ecosystem, and it creates this amazing loyalty around your product. But a poorly designed one, man, it just becomes a black hole. A constant source of support tickets, developer frustration, and a maintenance nightmare that just drains your resources for years to come.
So this brings us to our first set of core decisions, and it's all about naming and structure. Now, this isn't just about making things look pretty. The names you choose will literally define how intuitive and discoverable your API is for every single person who uses it.
So, here we have the two fundamental philosophies of API naming. On the left, you've got the resource-oriented approach. This is super common in REST. You treat your system as a collection of nouns, things like orders or users, and you perform actions on them. But on the right, you have the intent-oriented approach, which you see a lot in GraphQL. This focuses on verbs, the specific actions you want to take, like delete order or publish post. It's a subtle difference, but it's a really powerful distinction in how you model your entire world.
Okay, but before we can even send those nouns or verbs across the internet, we have to solve a really fundamental problem. How do you get a complex object sitting in one computer's memory all the way over to another computer's memory? Well, the answer is serialization. It's the process of turning that object into a sequence of bytes that can actually travel over the wire. And this diagram shows that whole process in action. You see System A takes some data, it serializes it into this stream of bytes, and then shoots it across the network. System B catches that stream and deserializes it, perfectly recreating the original object in its own memory. I mean, it looks simple, but this process right here is the magic that makes pretty much every network-based API work. Okay, so you did it. You launched your beautiful, well-named API. Awesome. Now comes the hard part, success. Because as more and more people start using it and your data grows, you're going to face a whole new set of challenges that are all about change and scale.
We've said it before. Your API is a contract. Your users build their software based on the promise that it's going to behave in a predictable way. But what happens when your business needs change, or you need to add a cool new feature? How in the world do you evolve your API without breaking that contract and causing total chaos for all your users?
Well, the answer is versioning, and here are the three most common ways to do it. Path-based is probably the clearest and most popular. The version is right there in the URL. Can't miss it. The other two, query parameter and header-based, they keep the URL a little cleaner, but they can be less obvious to developers. The real key here is just to pick one and stick with it. That's what lets you evolve your API while letting older clients keep working on the old version. Here is another great problem to have. Your API is so successful, you have too much data. A user asks for all their orders, and it turns out they have millions of them. If you try to send all of that in one go, you're going to crash your server, their client, and probably the network in between. It's just not going to work. The solution is pagination.
You serve up the data in manageable little chunks or pages. And this slide shows a fantastic example using something called cursor-based pagination. The client asks for 100 items. The server sends back those 100 items, but it also sends back a next cursor. It's like a bookmark. To get the next chunk of data, the client just makes the same request again, but includes that new cursor. It's a super simple but incredibly powerful pattern for handling massive datasets.
And finally, to protect your service from getting totally overwhelmed, you absolutely need rate limiting. This is such a critical defensive pattern. It stops any single client, whether they're malicious or it's just a buggy script running wild, from bringing your entire API crashing down. For any real production API, this isn't optional. It is an essential safeguard.
All right, let's move on to a topic that should never, ever be an afterthought: security. This has to be baked into your design process from day one. These are the absolute non-negotiables.
Security really boils down to 3 core pillars. First up, encryption. This protects your data as it's flying across the network so nobody can listen in. Simple enough. Second, authentication. This answers the question, who are you? It's all about verifying a user's identity. But once you know who they are, you need step 3, authorization. This answers the next crucial question, okay, what are you allowed to do? This is what makes sure a verified user can only touch the specific things they actually have permission for.
And this leads us directly to the single most important philosophy in authorization, the principle of least privilege. The idea is so simple but so powerful. You grant users only the absolute minimum permissions they need to do their job, and nothing more. That one concept is the foundation of a robust security model, and it dramatically reduces your attack surface.
So we've covered a bunch of specific patterns for naming, for scaling, for security. Now let's kind of zoom out and look at the high-level principles that tie all of this together and really define the philosophy of great API design. This slide is just a fantastic checklist that sums up our whole philosophy. It starts with knowing your audience. I mean, are you building for your internal teams or for the public? A great API makes the simple stuff completely effortless while still making the really complex tasks possible. It's designed to be hard to misuse, and when things do go wrong, it gives you clear, helpful error messages. And of course, as we've seen, it's always built for performance and protected with rate limits.
This is just the perfect note to end on, because after all the rules, after all the patterns, great API design is also a craft. It involves taste. It involves intuition. These patterns we've talked about, they're the tools in your toolbox. But you are the artist. The goal isn't just a functional API. It's an elegant one, an interface that is a genuine pleasure to use.
And so that's the question I really want to leave you with. As you go out and design your next API, just remember, you're not just writing code for today. You are building a foundation that could last for a decade. So you have to ask yourself, are you creating another support nightmare, or are you crafting a diamond?